Hey everyone, Be Bro here, and today we will be going through one of the questions from the series of integral tests. Now the integral test, as you know, it's like that integral from B to A. Sorry about my handwriting. We'll be going through that later on. So right now, let me start up by putting this problem on my board. Right, so use the integral test to determine whether the series is convergent or divergent. So we have this series of infinity when n equals 1. That is n over n squared plus 2. So now we have to evaluate the following integral. It's really simple. You just change n into x. Simple as that. And have b as infinity and a equal 1. And of course, you should always have a dx at the end. So now, in order to find out what the so we can't have infinity right there because that would equal divergent automatically. So instead of infinity, we have to change it to any constant letter, like t, for instance. It doesn't really matter if it's t and oh wait, I forgot to put limit t. Can you guys see that? In case you don't know, that's infinity. And I'm sorry about my handwriting. So next, so we put x squared plus 2, and that's it. That's down below when x is at the top, dx. And that will equal the limit when t approaches infinity. That would be half of ln x squared plus 2. Now it's half of ln because there's x at the top and x squared plus a constant number. That's gonna have to be the, of course, the fraction is similar to the natural log or ln, and of course you have to put it in half because there's an x, and if it's a 1 then it's just ln, no half. And then we put t right there and 1, so that will equal now the easier way to do it is to put half first and then the limit of t approaches infinity. That is ln t squared plus 2. And of course I changed it t and t from x because we're about to change x into the numbers, and since infinity is t, we have to put t in there. Minus ln 3, since 1 plus 2 equals 3. And you guys should know that now. Guess what? Because t is the only one, and we have nothing to eliminate or simplify, then we'll have to change t into back to infinity, and that's what we're going to have as our answer. So since this integral is divergent, because infinity does not equal 0, since it's divergent, so does the series. The series diverges. Let me use a different color. The series diverges. And that's that. Alright, quick edit there. I have another problem for you. So determine whether the series is convergent or divergent. So, and square root of n plus 7 over n squared. So some people might think it's a little tricky. Now, sometimes it's a little tricky, or some people may think, oh, what if I could do that? Oh, what if I could do that? Well, you can't. That's illegal. If you do that, you're going to math jail. That's what my high school teacher says. Alright, so instead, you could split those two. And that's okay. You can do that. So what you can do now is to have these two separated. And sometimes you can simplify a few of these parts. For instance, this is n to the half over n squared. And since n to the half and since n squared is at the bottom as a minus, you could put n square root of n down below, well, or n to the half down below as 1 over n to the 3 half. And you could keep the 7 over n squared because there's no need for simplifying unless you want to. Now, guess what? It didn't tell you what specific tests you need to do. So you can choose whether you do a divergence test, integral test, p-series, uh, absolute series test, power series test, any kinds of tests. Can't really count them any specifically, but yeah, just pick any of those and see if they helped you a lot. If they didn't, then pick another one. So for this question, it looks like I can do a P series because in the P series, there's a power at the denominator, and P series are very easy to use because in this P series, if the let's, pre- let's pretend it's n to the P, and if P is okay, that my mouse is irritating. If P is greater than 1, then it converges. Yay! But if P is less than or equal to 1, then it diverges. Boo. So for that part, we see that P equals 3/2, and it's greater than 1. So that converges. Ding. And the next one, P equals 2. So that 2 converges. Ding. So the sum of two the sum of two series converges. So in conclusion, the original series converges. So the series approaches infinity when n equals 1. So 6 to the power of n over 9 plus 11 to the power of n. So what we can do is put less than and have just 6 to the power of n over 11 to the power of n. And that is similar to 6 over 11 to the power of n. So now it's going to be more likely a geometric series. So when r equals 6, so since so we're going to have 6 equal 11, 6 over 11 equal to the absolute value of r, and r must be less than 1 if and that converges, but if it's greater than 1, then it diverges. But guess what? 6 over 11 is less than 1, so that converges. Ding. So the original series converges. Alright, quick edit there. Here's one last question for you, and then I'll be done for now. So, this is another comparison test. When the series approaches infinity when n equals 1, 9 to the power of n plus 1 over 8 to the power of n minus 7. So you do know that you're looking at, the exponent of 9, which is n plus 1 times 9 times 9. So 9 to the power of n times 9 to the power of 1, which is just 9. And that's it all over 8n. And you see I did a greater than. So that's going to equal, now since there's 9 times 9 right there, now the regular 9 will have to be outside. So 9 over 8 to the power of n. And that will equal 9 series when it approaches infinity n equal 1, 9 over 8 to the power of n. Now, once again, the absolute value of r, which will equal to 9 over 8. And since it's greater than 1, it diverges. Boo. So, the series diverges. And that's it. So thank you all so much for watching. If you have any questions or concerns, leave your comments down below, which really helps a lot. And if you like this video, hit that like button, which really gives me some love and support. And also subscribe me as P Weather Pro. And as always, thanks for watching. Shalom. Dobbs America.